If we limit ourselves to conventional airplanes, with wings and jet engines, not rockets, then the Lockheed S-71 Blackbird, flying at 85,000 feet, 25,900 meters, is as close to space as any plane can currently fly. It is very high up but still within the Earth's atmosphere. Without the atmosphere, the engines would stop working and the wings would not provide lift, so the plane would fall. An important point to remember: unlike what you might think, there is gravity in space. When you see astronauts float weightlessly around the International Space Station, they are not really weightless. They are falling towards the Earth all the time. The ISS is also falling towards the Earth at exactly the same speed. So relative to the ISS, the astronaut appears to be weightless. The trick is that the ISS is in orbit, so as it falls it is also moving horizontally at a huge speed such that its fall misses the Earth. This constant fall creates a circle or orbit. That is how the ISS, shuttles and other satellites stay up. To get into orbit, you have to go really fast. Not just up, but horizontally. The first satellite, Sputnik, launched by the Soviets in 1958, traveled at about 28,000 kilometers per hour. That is a massive amount faster than the fastest plane ever built. The SR-71 Blackbird does Mach 3.2 or more. That is about 3,540 kilometers per hour. The SR-71 is fast but not fast enough to get into orbit. There is no currently operating jet engine that can get you up to the speeds required for orbit. Rockets are the only way orbit has ever been done so far. Large passenger planes can't fly much higher than about 12 kilometers, 7.5 miles. The air is too thin above that altitude to hold the plane up. Some kinds of planes can fly much higher, and one special NASA plane, named Helios, flew to about 30 kilometers, 19 miles, which is far higher than any other plane has traveled. At that altitude, the air is 100 times thinner than at sea level. The air gets thinner and thinner the higher you go, until there's hardly any air at all. In other words, it's nearly a vacuum up there. Even the lowest Earth-orbiting spacecraft orbit at around 200 kilometers, 125 miles, above Earth's surface, far above the thick air we are accustomed to and much higher than any plane can reach. Most Earth orbiters, though, are placed at much higher altitudes to do their jobs. Some of these jobs include scientific observations of the universe that are better than scientists can make when looking through the air, as well as observing Earth's weather and long-term climate changes, taking pictures of Earth's changing surface, and studying pollution in the atmosphere. To get a spacecraft to even the lowest Earth orbit requires a rocket. So how is a rocket different from an airplane? Rockets do not depend on air, even for burning their fuel. Rockets take advantage of some basic laws of nature that were discovered by the brilliant scientist Isaac Newton late in the 17th century. One of these, called Newton's third law, says that for every action there is an equal and opposite reaction. This explains what is going on when you blow up a balloon, then let it go without tying a knot. The air rushes out of the mouth of the balloon and that pushes the balloon in the opposite direction. This law also tells us that, to build a powerful rocket, we need to shoot out a lot of high-speed material opposite the direction we want the rocket to go. That is exactly what a rocket engine is designed to do. Most rockets use high-speed exhaust gases from burning rocket fuel to propel themselves up and away from Earth's surface to the vacuum of space. Unlike planes, they don't need air to lift them up.
You make me